When we talk about the past and the future, most people drift toward mystery, destiny, or philosophy. It's tempting to imagine time as something magical, separate from the world of cause and effect. But there is something far more astonishing: the idea that the same simple rules that govern falling apples, swinging pendulums, and orbiting planets also knit the past and future together. If you want to understand why yesterday leads to today, and today points toward tomorrow, you don't need spells or mystics. You need curiosity, patience, and the willingness to look closely at how nature behaves. Think about a ball rolling across a floor. If you watched a video of it backwards, you might have to look pretty carefully to know which direction was the real one. The laws of motion. Don't complain if you reverse time in the equations. They work just as well going forward as they do going backward. That's the first big surprise. Nature's rules themselves don't come stamped with arrows saying this way only. What changes isn't the math, it's our experience. We wake up and move forward through events, collecting memories of what has already happened and guesses about what might come next. So the question becomes, if the laws don't prefer the past or the future, why do we? The answer lives in the way tiny causes accumulate into big effects. Every movement of air, every collision of atoms, every transfer of energy quietly keeps a record. A broken glass isn't just broken. It's the result of billions of microscopic interactions moving in one coordinated direction, from order into disorder. You could, in principle, run all those collisions backwards and reassemble the glass. But in practice, the number of ways for things to fall apart is unimaginably larger than the number of ways for them to organize themselves neatly again. Nature isn't being dramatic, it's simply following statistical likelihoods. Over time, those likelihoods write the story we call history. This is where the connection between past and future becomes truly beautiful. The present moment is not floating alone. It is the result of everything that came before, filtered through physical laws that quietly, relentlessly do their job. And at the same time, those same laws constrain what the future can be. They don't script every detail. There's room for chance, probability, and uncertainty. But they set the boundaries. A dropped stone won't suddenly fly upward. Heat won't spontaneously rush from cold space into a hot cup of tea. The future must respect the rules, just as the past did. Seen this way, time stops feeling like a mysterious river dragging us along. It becomes a relationship, causes shaping effects, patterns emerging from countless interactions, order and disorder play out on a cosmic stage. The more closely we look, the more we see that understanding the past is not about nostalgia, and predicting the future is not fortune-telling. Both are acts of paying attention to the laws that hold everything together. And here's the quiet miracle: the laws themselves are simple, but their consequences are vast, from stars forming in distant galaxies to the thoughts moving across your mind right now. All of it is stitched together by the same principles. No mysticism required, only the courage to ask honest questions and the joy of discovering where the answers lead. Because once you realize the universe is understandable, even in its deepest mysteries, you also realize something else. Standing in this moment, aware and curious, is one of the greatest powers. We all have this ordinary, everyday feeling that time moves in one direction. You wake up, you brush your teeth, you go through your day, and by evening you are certain that the morning is behind you and the night is ahead. Nobody confuses the two. Yet when you look at the fundamental equations of physics, they don't clearly insist on this forward flow. They allow the movie to run backward. Just fine. So where does this deep sense of direction come from? Why does life feel like a path we walk in one way only, from past into future, never the other way around? The key is hidden in something that sounds dry at first: disorder. Or, to use the scientific word, entropy. Imagine a tidy room and then a messy one. There are millions more ways for a room to be messy than for it to be organized. If you live in that room long enough, you don't need a physicist to tell you what's going to happen. The socks drift, The papers pile, the pencils wander. That's not because the universe hates neatness. It's because disorder is simply more probable. Given enough interactions, enough bumps and jostles and tiny accidents, systems naturally slide toward states with more ways to exist. This quiet, relentless slide is the arrow of time. Think of an egg cracking on the floor. The shell shatters, the yolk spreads, the mess grows. You will never walk into a kitchen and see the yolk leap up, pull the shell together, and settle calmly back into its carton. Physics doesn't forbid that backward miracle in an absolute way, but the odds are so unimaginably small that, for all practical purposes, the universe will never spend its precious energy arranging such a perfect reversal. There are simply far more ways to be broken than to be whole. And so, step by step, moment by moment, the world keeps marching into states with more possibilities, more disorder than the ones before. This is not a gloomy story. In fact, it's one of the most profound and beautiful ideas we have. The arrow of time is not painted onto the universe from outside. It emerges from the collective dance of countless particles, each following simple rules. From breathing lungs to spinning galaxies, everything we know and love sits on top of this grand statistical tendency. Memory works because traces of events linger in the patterns of matter. History exists because each moment leaves behind a range, ments that are unlikely ever to be undone. And here's the twist that makes it truly fascinating. Inside this general rise of disorder, pockets of remarkable structure can appear. Stars, planets, weather systems, living creatures, thinking minds. They form not in spite of the arrow of time, but because of it. Energy flows from hot to cold, from concentrated to spread out, and along the way it buoys. LDS whirlpools, storms, ecosystems, and ideas. Order blooms temporarily as the universe heads toward greater overall disorder. That is not a contradiction. It is the very engine of complexity. So when you feel that tug of time pulling you forward, understand what you're sensing. You are part of a vast physical story. You are surrounded by processes that cannot easily run backward. Melted ice 1. Reassemble into a sculpted cube. A burned log won't leap back into being a tree. The arrow isn't drawn by imagination. It's carved by probability. And even though the underlying equations are reversible, the world we live in is not, because it is made from oceans of events where more likely wins again and again. Once you see that, the past feels a little more solid and the future a little more mysterious. But neither seems magical anymore. They are simply the two directions of a universe whose rules are simple, but whose consequences are thrillingly rich. And the astonishing realization is this: every second that passes is not just time moving, it is the universe choosing again and again a path that opens into possibility. In everyday life, we carry this quiet conviction that things just can't be undone. You drop a glass and it shatters. You mix cream into coffee and it swirls into a uniform color. You strike a match and the flame eats the wood until there's nothing left but ash. Nobody expects the shards to leap off the floor, the cream to pull itself apart, or the match to regrow. These processes feel final, permanent, irreversible. And yet when you write down equations that describe the motion of every atom involved, something astonishing happens. The math doesn't share our certainty. The equations say, run me forward, run me backward. I work either way. That sounds almost like a trick. How can a world filled with broken things and spent chances be built on equations that don't care which direction time is going? The answer lies in the incredible gap between what is possible and what is likely. On paper, if you could reverse every single motion of every single particle with absolute precision, the broken glass would reassemble, the cream would unmix, the smoke would glide back into the matchstick. The laws allow it. But the slightest error, the tiniest deviation, sends the whole reversal flying apart. It's like balancing a pencil on its point. Possible in theory, vanishingly fragile in practice. This is where our intuition gets humbled. We think something is impossible because we never see it, but in reality it is simply drowned in improbability. The universe contains unthinkably many particles, jostling and colliding every second. For everything to retrace its steps exactly would require an orchestration so perfect that one star, a molecule bumping a little too hard, ruins the entire performance. So, nature takes the easy road, not because it's lazy, but because the easy road has an astronomical number of ways to happen. And we label this drift, this one-way slide, as irreversible. Once you realize that, a funny kind of clarity appears. Irreversibility is not written into the fundamental rules, it emerges from complexity. It's a property of large systems, kitchens, weather, ecosystems, civilizations. We see no going back, not because the laws forbid it, but because the conditions required for going back are so delicate that the universe, busy as it is, practically never arranges them. The equations stay calm and symmetric. Reality rushes ahead, messy and real. And this tells us something profound about RPL. Ace in the story. Our memories exist because events leave traces. Those traces are patterns that are nearly impossible to unwind. Footprints in sand, ink on paper, signals in our neurons. Each is a record made by countless microscopic motions that would be fantastically unlikely to reverse. That is why remembering the past feels natural, while remembering the future feels absurd. The traces have been laid down yet. Still, there's something hopeful tucked inside this understanding. If irreversibility is born from chances multiplied across trillions of interactions, then creativity, growth, and change also arise from that same ocean of possibilities. We are not trapped by fate, we are carried along by processes that create novelty as they unfold. There is room for emergence, for struct, for meaning, not because the laws bend for us, but because the universe, under those very laws, produces forms that surprise us anyway. So the next time something seems final, it might be worth remembering what the equations quietly whisper. They don't draw a hard line between can and can't. They draw a line between what is allowed and what is so fantastically unlikely that you'll never witness it before the stars burn out. In that difference lies our sense of direction, our feeling of time, and the drama of every moment we live. And once you see that, the ordinary world reveals its hidden truth. The impossible-looking flow of life is simply possibility, choosing its most natural path. When we talk about the future, we like certainty. We want to know what will happen, not just what might happen. We want predictions that feel like guarantees. But the universe doesn't sign contracts. Instead, it offers something subtler and more honest, probability. Rather than telling us exactly which domino will fall next, it shows us the patterns in how dominoes usually fall and invites us to think in terms of chances instead of certainties. Consider weather forecasts. When someone says there's a 70% chance of rain, people sometimes laugh if it doesn't actually rain. They were wrong. But that statement never promised a storm. It meant that, out of many similar situations, rain arrives in most of them. The forecast is a window into likelihood, not destiny. And that is how nature often speaks. It doesn't whisper, "This is what will happen." It says, "Given everything, we know, this is what usually happens." Now shrink that idea down to the microscopic world. A gas in a room is made of trillions of particles darting around at incredible speeds. Nobody, not even the most brilliant scientist, could possibly track each individual path. And yet, astonishingly, we can predict with great accuracy how pressure, temperature, and volume will behave. That's the miracle probability. Ignorance of the details does not prevent understanding of the whole. The big picture becomes clearer when we accept that the small picture is forever fuzzy. Then quantum mechanics comes along and pushes this lesson even deeper. At that scale, uncertainty isn't just about things being too complicated to calculate. It's built into reality itself. Particles don't sit politely in one exact position with one exact speed. Instead, they exist as spreads of possibilities, and only when we measure them do specific outcomes snap into place. The future, at this level, is not an unwritten script waiting to be read. It is a space of potential events, each carrying its own probability. This doesn't make the world chaotic nonsense. In fact, it's the opposite. Probability brings structure, to uncertainty. The more experiments we run, the more clearly the patterns emerge. A radioactive atom may decay at an unpredictable moment, but gather enough atoms together and their overall behavior becomes strikingly regular. We can plan, build technology, and do science with astonishing precision, not by defeating uncertainty, but by understanding it. And there's a lesson there for the way we live. We sometimes imagine the future as a single narrow track we are either meant to follow or doomed to miss. But in reality, the future branches. It is shaped by constraints, by physics, by chance, and, crucially, by choices. Our actions don't rewrite the laws of nature, yet within those laws they tilt the probabilities. A small decision today can make certain outcomes more likely and hers less so. That's not fate, that's participation. Embracing uncertainty doesn't weaken us. It makes us better thinkers. It keeps us honest about what we know and humble about what we don't. It encourages curiosity instead of overconfidence, exploration instead of dogma. When we say, "I'm not sure, but here's what the evidence suggests," we're not admitting defeat. We're aligning ourselves with the way the universe actually works. So the next TI, you wish the future would come with guarantees. Remember this: certainty may feel comforting, but probability is what gives us room to learn, adapt, and imagine. The unknown is not a flaw in the system. It is the very space where possibility lives. And in that space, guided by reason and open to wonder, we discover that not knowing everything isn't a limitation. It is an invitation to keep asking deeper questions and to keep moving forward with courage. When you shrink your attention down to the tiniest scales of reality, something surprising happens. Time stops behaving like the tidy, ticking clock we're used to. In our everyday world, things move smoothly. A car travels down the street. A shadow slides across the wall. A second passes, then another. We imagine that, deep underneath it all. Nature must be running the same simple movie, frame after frame, neatly ordered. But the microscopic world refuses to play along with that comforting picture. Down there, time becomes slippery, possibility replaces certainty, and our intuition starts to wobble. Take a particle, an electron, for instance. You might imagine it tracing out a single path through space and time, the way a TI. My marble would roll across a table. But quantum mechanics asks us to consider something wildly different. Instead of choosing one path, the electron behaves as though it explores all the paths at once. Straight lines, curves, loops, ridiculous zigzags. Every possible route contributes to what ultimately happens. The future, in this picture, isn't a single pre-written story. It's a vast collectio, N of might be's, each whispering into the final outcome. And here's the twist that can really scramble your sense of time. These possibilities don't care about our preferred direction. When you write the equations, the contributions from forward and backward in time get mixed together in a subtle mathematical dance. The world doesn't evolve like a marching band, stepping in unison from past to future. It behaves more like a shimmering interference pattern, where what might have happened and what actually does happen blend in ways that challenge everything our common sense has trained us to believe. This doesn't mean the universe is chaotic nonsense. It means the rules are deeper than the pictures our everyday brains evolved to use. We built intuition from throwing rocks, pouring water, lighting fires, not from tracking electrons tunneling through barriers or photons interfering with themselves. So when quantum mechanics says that a particle can be in a superposition, existing as multiple possibilities at once, our instinct screams that can be right. And yet, experiment after experiment says yes, it is. Now, consider time again. We like to imagine that the present moment is a thin, sharp slice, the boundary between what has already happened and what is yet to come. but quantum reality blurs that boundary. Outcomes aren't fully settled until interactions and measurements occur. Events that seem firmly in the past can still influence how earlier possibilities combine to create what we finally observe. It's as if the universe is willing to keep its options open longer than we're comfortable admitting. Instead of feeling threatened by this, we can find wonder in it. The strangeness is not a bug, it's a clue. It tells us that the universe is not built to satisfy human expectations. We're the ones who have to stretch. We learn to trade pictures that feel simple for explanations that are accurate. We learn to say, the world is more subtle than I imagined, and that's exciting. What makes this remarkable is how well it works. Using these strange rules, we've built lasers, computers, medical scanners, GPS systems, technologies that rely on the very features that seem so bizarre. The predictions are precise to man. Decimal places. The theory is tested every day, and still, when we step back and ask, but what is time really in a universe like this? We find ourselves right at the edge of understanding, staring into a mystery that is both humbling and beautiful. Perhaps that is the deepest message hiding inside all this quantum weirdness. The world is not obligated to look simple, neat, or intuitive. It is obligated only to be consistent with itself. Our job is not to force reality to match our expectations, but to let our expectations evolve as we learn. And the more we discover, the clearer it becomes. Even in its strangest corners, the universe invites us with patience and courage to keep following the truth wherever it leads. If there's one habit that keeps showing up whenever we make progress in understanding the universe, it's not confidence, it's doubt. Not the gloomy, paralyzing kind, but the lively, curious version that says, are we sure? Could there be more to this? Time is one of those subjects that tempts us to settle for simple answers. It feels so familiar, so obvious that we forget to question it. Seconds tick, clocks move, days pass. What else is there to say? But the moment we let curiosity pry open that everyday certainty, the world becomes far more interesting. Curiosity is the impulse to lean closer instead of looking away. When you notice the steam rising from a kettle and wonder why it curls the way it does, you've already stepped into the same spirit that leads people to ask how stars are born, or why entropy increases, or why equations don't seem to care which way time flows. That simple question, asked sincerely, is the engine of science. It doesn't demand that the universe behave a certain way. It listens, it watches, it runs experiments, it allows reality to surprise us. And then there's doubt, the partner of curiosity. Doubt refuses to treat any explanation as sacred simply because it feels comfortable or has been repeated for a long time. It pokes holes, it tests assumptions. It says, if this is true, we should be able to see its fingerprints somewhere. Let's check. Doubt is not disrespectful to knowledge. On the contrary, it is the highest respect you can give an idea, the willingness to challenge it and see whether it stands. When we apply curiosity and doubt to time, we start noticing things that usually slide right past our awareness. Why do we remember the past but not the future? Why is breaking a glass easy but unbreaking it impossible in practice? Why does probability sit at the heart of predictions about what comes next? Bit by bit, each honest question chips away at our comfortable picture and replaces it with something deeper. Not always simpler, but far richer and closer to the truth. The beautiful thing is that this attitude doesn't demand certainty from us. It invites humility. We're allowed to say, we don't completely understand his yet. In fact, that sentence is often the doorway to discovery. The greatest breakthroughs grew out of places where people admitted confusion and then decided not to turn away. They followed their puzzlement like a trailhead into the unknown. And look at what that has given us. A world where we can describe the birth of galaxies, manipulate the quantum behavior of particles, navigate spacecraft across the solar system, and explain why time seems to have a direction at all. None of that came from pretending we already knew everything. It came from being brave enough to admit that we didn't, and curious enough to keep going anyway. The is also something deeply human about this way of thinking. Curiosity keeps us young, even when the years move forward. Doubt protects us from the illusion that the first explanation is always the right one. Together, they create a mindset that is flexible, resilient, and alive, a mind willing to update itself when the evidence says it must. That willingness is not weakness, it is strength. When we stand here thinking about past and future, about arrows of time and strange quantum possibilities, the real lesson is not just about physics. It's about how we approach mystery itself. The universe does not give us answers wrapped with neat bows. It offers clues, patterns, hints, and then waits to see whether we care enough to follow them. And if we do, if we keep asking, keep questioning, keep allowing wonder and skepticism to work together, instead of fighting each other, something extraordinary happens. The world becomes less like a fixed story and more like a grand conversation, one in which we are not just spectators but active participants, forever learning, forever revising, forever widening the circle of what we understand. And in that ongoing conversation, the most powerful sentence we can carry with us is simple: there is always more to discover. Thank you so much for watching. If this video inspired you, be sure to like, share, and subscribe to be inspired from life for more motivational content. And remember, no matter where you are in life, you have the power to change your future. See you in the next video.